What's the evidence that the planets are a lot closer than we're told? We first need to understand the limitations of our eyes. The cones of our eye need at least 0.01 lux of light to see color. This goes for any large or extremely small colored object or light. This is well documented in many experiments and papers. At the planet's stated distances from the Sun, we can use the inverse square law to work out the amount of light each of the planets will receive. Given the percentage of light each planet reflects, their distance from Earth, and the radius of each planet, we can work out how much of their reflected light reaches Earth and our eyes. We are using GeoGebra to input the math and numbers to produce an interactive calculator. Let's start with Mars. At its stated distance, this is the amount of light hitting the Earth's outer atmosphere. We then have an additional loss of light as it passes through the atmosphere to your eyes. The lux level would need to be over 200 times greater for you to perceive the faintest hint of color. It's well below the level of light needed to even see it. As we look at each planet in turn, they get further from the Sun and Earth. Thus the amount of light reflected back to Earth gets lower and lower. None hit the light requirements to be able to see them directly. Our Moon. Given the Moon's distance, its radius, and the amount of the Sun's light a full moon reflects, the calculation for the amount of its light hitting your eye on Earth is reasonably accurate. However, it's also accurate with the Moon being smaller and closer. Telescopes. Telescopes making the light brighter to our eye seems to be greatly misunderstood. Due to the optics, they all have a loss of light. In some cases this is over 30%. Yes, they do collect more light, but there are limitations to how much you can magnify. Here are 3 different aperture sizes with their light gathering power. The square root of the light gathering power gives you the maximum magnification to get equal brightness with a larger image. Anything above this is reducing the level of light to the rods and cones of our eye. Equal brightness magnification is when a telescope's image appears as bright as what you'd see with your naked eye. Your eye's rods and cones receive the same amount of light as they would without the telescope, but see a larger image. Higher magnification spread light over more rods and cones, so each gets less light. Telescopes actually prove planets are close. A case in point, Neptune. Neptune, at 30 times further away from the Sun as Earth, receives only 144.5 lux of light from the Sun. It reflects only 79.5 lux of that light. It then needs to travel 29 AU, or Sun-to-Earth distances to our eyes. This is the amount of light hitting Earth. To directly see Neptune, the light needs to be over 38,000 times greater. To see its blue color, nearly 4 million times. Neptune is not visible with the naked eye, you need a telescope. The Backyard Astronomer's Guide recommends around 100 times or more magnification to see Neptune and its color. The problem is, this will be well above the equal brightness magnification. The light from Neptune will be 33 times less than with the naked eye. The light gathering power of a telescope only helps if Neptune is closer and smaller. Its angular size is too small for our eyes to resolve. Using a telescope with 108 times magnification gives a larger angular size and makes it visible. Our eyes need 0.01 lux of light to see the faintest hint of color. 2. They need 0.0001 lux to directly see a light or object. 3. The planets at the distance mainstream science states don't send our eyes anywhere near the levels needed. 4. Telescopes don't increase the lux level to the rods and cones of our eye. They reduce the level, a greater reduction of light, with greater magnification. 5. If telescopes don't increase the level of light to rods and cones, stars cannot be too dim to see, they must be too small to see. And 6. Telescopes' magnification alone makes more planets and stars visible. Thus they must be closer and smaller.